squared minus 12x minus 32. Okay. And what I see here is that this negative leading term is bad.
Yeah.
So we generally want to eliminate that. So you can do that by multiplying everything on the left by -1 and everything on the right by -1. But that has the immediate consequence of flipping the inequality. So that becomes x squared plus 12x plus 32 less than 0. Is that okay? Is that clear?
Yes.
All right. Now this is the factoring of type a equals 1. There's really a 1 in front here of the x squared. You're looking for two numbers that multiply to 32 but add to 12. Okay. So the approach here would be to take 32 and start dividing it by 1 and by 2 and by 3 and so on. And eventually you'll get two numbers like 32 divided by 1 is 32. Is 1 and 32 add up to 12? No. When you divide it by 2, you get 16. Is 2 and 16 add up to 212? No. Keep going here. I mean, you'll eventually you'll get it, right? 32 is not divisible by 3, so you wouldn't put a number here, but it is divisible by 4. It's 8. 4 and 8 add up to 12. So x plus 4, x plus 8 less than 0, like that. Now, do you remember what we did yesterday when we got to this point?
We did the number line.
Yeah, but I think you're probably, I think we did set them equal to 0 first. I can't remember exactly what we did. I think it was this. And then those two numbers go on the number line that we solved for. So x is -4, x is -8. And so those are the numbers that go on the number line here.
Right.
So -8 here, -4 here. You were graphing those nicely. The next thing here is to come up with test points.
Right.
Okay, so something in each region. Try for 0 if you can, maybe -6 and -10. And from here, you've got to try them. You've got to try them in either the original or the factored form, whichever you like.
We're doing the factored form first.
All right, why don't you go ahead and do that for each of these and tell me what you come up with.
I'm gonna use the calculator.
Absolutely.
Yeah, that calculator is growing on me now. Okay, I'm gonna start with -6.
Okay.
Okay, so negative. So six. With that equals -4.
Okay, you read it as negative.
Okay, now I'm gonna do with -10.
All right.
That did not make sense when I said that, but that's okay. That's gonna be positive, that's gonna be 12.
Okay.
And now when it comes to 0, it will be 32. So
Positive. Good. Now, if you look back, we're looking for where it's less than 0, which is in this region here. Does it include the endpoints? And that's based on this symbol here, whether it does or does not.
So I lost it.
With the less than, we yesterday made some notes that with less than or greater than, it always went with a open dot and it always goes with the parentheses.
Right.
So this would be all the numbers between -8 and -4. And in parentheses.
Got it.
Okay, on to number 8. All right, here we go.
Also, the reason I didn't send you the next lesson is because it's locked. It's a review lesson, and I think so that's why.
All right, well, we'll see what we could do here. Let's see how it might, who knows how long this will take. I never a good estimate of that sometimes. So
Mhm.
this new problem here, different than some of the others. If you noticed, all the others have been like less than 0 or greater than 0, or but we don't have that here. We really want this to be 0 on the right. To do that, you subtract 14x from both sides. So this is x squared minus 14x plus 49 less than 0.
Mhm.
Okay. So your goal is always to make it, something with 0. 0 should be on one side of the equation here.
Got it.
All right. Now on the left here, this is what's called a perfect square trinomial. There's 5 different major types of factoring that you might see. And this is one of them. So like you're supposed to, and I say that like in air quotes, you're supposed to like see this and be like, oh, I know what it is. It's a perfect square trinomial. I know how to do it. It still works the same way as the previous ones. You're trying to find 2 numbers that multiply to 49, but add to minus 14. It's just that when you get the answer, you say, oh, maybe I should have known that in advance.
Yeah. Well,
Okay.
I know for this one, it would be -7.
Yes. So this is x minus 7, x minus 7. The 2 negatives make the positive when you multiply, but then they add to negative 14. This is considered a double root because both of these end up being equal to
Yeah.
7. All right. Okay. Now go to a number line
Mm-hmm.
and you got to test points. Now you've only got 2 regions this time to test points in, which is nice. So you're going to test points in the left and the right. So maybe 0 and 10. 0 is always a good choice. And again, you can test them in the factored form. The original doesn't matter. Whatever you feel like.
I'll do factor form. I'll
Okay.
first do it with 0 minus 7, and then, which will be 49. I hope I did that right because
Yep, you did that. That's perfect. Positive.
it's possible. This time the pattern might be changing. Might be. I'm not sure because. Oh, yeah. Okay, so for the. So I. So for now the 10, I actually put 7 instead of 10.
You,
So
you cannot try 7. 7 is the critical point.
yeah, that's why I just.
Yeah, so you have to, and if you don't like 10, you can try 8 or you can try 100, but typically we're more comfortable multiplying by, nice numbers.
I feel comfortable doing 10. So and then I got 9.
Okay, so
Positive.
positive also. Okay, so that's interesting.
That's the first time that we got the pattern throughout the whole lesson with 2 positives and no negatives.
So I wonder, so this is where you might say, well, I wonder what the graph looks like. Okay, what does the graph of this thing actually look like? So I'm going to quickly snip that in to the workspace for us so you can see that. And then I'm going to ask you a question to hopefully help explain this. So here's the graph. So when we ask where it's less than 0, what we're really asking is below. Less than 0 means below
Right.
the x-axis. And that's my question to you. Does this graph ever go below the x-axis?
No, wait.
No.
No.
So this has no solution.
Oh, wow. I mean, I kind of assumed that since we didn't also have a negative in there because we had 2 of the same numbers. So
That's right. So again, like one of the things that could happen here is they could want, I don't know if you've seen this for empty set. Sometimes they like the word no solution. There's another way to show no solution, which is a set without anything in it.
right.
These are kind of more formal, like most classrooms are like, yeah, no solution's good. You kind of know based on what you've seen in the lesson.
Yeah.
So that. Okay, if that's clear, we can move on to number 9.
All right. Yeah, I'm ready.
Okay. All right, so just like in the previous problem, you really want it to be 0 on one side, which means you have to get rid of this 3x and get rid of this 5. How do you do that? How do you undo these two things on the right-hand side?
Wouldn't you subtract?
Yes. Subtract 3x, subtract 3x, subtract 5, subtract 5. So you can do that right underneath. You don't have to make a big deal out of it. The 3x's do cancel, and it becomes x squared minus 25 greater than or equal to 0.
All right.
So this factoring should also look familiar to you. You should say, oh, I've seen that before. In fact, number 6 and maybe number
Well,
one.
well, aren't they like perfect squares where it's gonna be x plus 5 and then x minus 5?
Yes, that's the correct answer. The name of it is called difference of squares.
Oh yeah.
If you think that's important to remember.
No, it is important because then like because vocabulary and for math is important as well.
Yes, yes, yes. Okay, this is great. You've got them down. What's the next thing to do here?
X minus 5 equals 0 and then x
Good.
5 equals 0, which would be x can equal positive 5 and negative 5. So
Okay. So I want you to make your number line,
mhm.
test your points, and let me know what you come up with. You get to pick the points this time. I just want to know whether it's positive, negative, whatever you.
All right. So one of the test points are going to be 0.
Okay.
Another one, I want to do -7.
Okay.
-7, and then let's do +7 for +5. So yeah. Okay, I will now try that out. So for -7 and 5, I got +24.
It's a positive here.
Yes. Now for 0. I think I'm finally getting the hang of the Desmos calculator.
Nice.
Okay, -25. And then a +24 again for the 7 on the test point.
Okay. And I'm sorry, maybe you didn't tell me the one in here.
Oh, it was a negative.
Good, good. Okay, now we're interested where it's greater than or equal to 0.
Isn't that like a closed dot?
It is, but you're looking for the plus regions.
Oh yeah.
And then like you said, it's good, and we haven't been doing that, but we're going to do it now. We want to put filled in there because it includes those points. Now, if you go left forever, that is minus infinity. And if you go right forever, that's positive infinity.
Right.
So there are two intervals here. One goes from minus infinity to -5. The other interval goes from 5 to infinity. Now, for the infinities, they always get paired with parentheses.
Okay.
So there's always a parenthesis with an infinity. With the numbers, it depends on whether it's a filled in circle or not. So the filled in circle goes with these symbols here and the brackets.
Got it.
So this would be bracket, bracket. And then, not to further confuse this, but because there's two regions, you typically put what's called a union operator in between there. Like that.
Got it.
All right, we'll move on to part C, apply your knowledge.
All right.
All right, Nathan is a product manager for a home security company. Through testing and focus groups, he has modeled the equation P equals minus parentheses X minus 32 squared plus 1,000 to represent the profit in thousands of the price for a new home security camera. For the price in dollars at which Nathan can make a profit of at least, that's important there, at least 471,000. Show your work as is done in lesson content, include units of measurement. Hint, use 471 as part of the inequality you set up, not 471,000. Okay, so a couple things here. One is you have to extract the important information. The important information is the equation, this at least 471,000, and the fact that the profit is in thousands. So what that means is 471,000 is really 471.
All right.
You sometimes see this, especially when people talk about maybe home prices, they don't necessarily want to give the full number. I don't know if that's like the fear of talking about how expensive it might be, but it's what it is. That's this thing. The word at least translates to greater than or equal to. So there's a few of these sort of like words that you have to be able to convert. At least is one of them. If you had another problem where it said at most, that's less than or equal to. And there's variations on it. It's more about the English language, which isn't great in some cases, but that's what we've got to deal with. So the equation is minus parentheses X minus 32 squared plus 1,000 at least 471, like this.
Got it.
Okay. Any idea how to proceed on something like this?
Well, first things first, we would have to subtract the 471, so we can
Yes.
have a 0. So
Yes. Let me quickly check something here. This is one of those where I want to make sure that okay, yeah. So they've chosen wisely here. So I'm going to subtract 471 from both sides. And I'm going to do something here that may not seem like, you may wonder why we're doing that. I'm going to switch the order. So 529 minus X minus 32 squared greater than or equal to 0. So I just put the result over here to the left minus this. Okay, now 529, believe it or not, is 23 squared.
All right.
Okay, the reason that I'm showing you this is because this line is now what's called difference of squares.
Got it.
So just like when you were doing the much easier version up here where it was X squared minus 25, you take the square root of the first, the square root of the second, and that's what you write here. So it's a little awkward. So I'm going to show the formula here, A squared minus B squared, but I want you to see that A is really 23 and B is really X minus 32. And so this formula is always written as A minus B, A plus B. So in your problem, it becomes 23 for A minus, now B really is X minus 32 in parentheses. I probably should have showed that. Let me update that a little bit here. X minus 32, and then 23 plus parentheses X minus 32 greater than or equal to 0. This is considered a higher order type problem with a substitution. There's still a difference of squares problem. It's just that it involves what's called a substitution, which I've kind of shown you here. Hopefully this is clear, stepping through it with A and B.
Yeah.
Okay, it'll get better here in a moment. So you do distribute this negative to both inside parentheses. So it's 23 minus X plus 32. And on the right here, you can drop the parentheses like that. And now you can combine like terms
Mhm.
in the parentheses here. So the 32 and the 23 combined to 55 minus x, which, okay, that's not so bad. And then the other one here, 23 minus 32 becomes x minus 9, like that.
Mhm.
Okay. Is that okay so far?
Yes.
Okay, so now you're going to set them each equal to 0, which we've done a bunch of times now. You're going to get your x values. Okay, x is 9, x is 55. Okay. Now this time on our number line, we need to make a small little adjustment. So let me know when you're caught up here so we can talk about that.
I'm almost caught up. I'm just drawing my number line. Okay, I'm caught up now.
Okay, so if you go back to what the actual physical problem is, the physical problem is the price or the profit in thousands. And the question is, well, can you have negative profit? And this is sort of a question where I would say, no, you cannot. So I would tell you to stop at 0. This might be something to ask your instructor about by email and say, should the number line really extend forever? In business, there are such things as negative profits, but it's kind of one of those things where the physical problem has a different interpretation than just the math. Like just solving the math, you'd go on forever. The physical problem is like you wouldn't run a business if you had a 0 profit in general.
Mhm.
Okay, so having said all that, you still need to test 3 points. Can you do, and you can test them back here. So will you go ahead and do that for us, please?
Yeah. So can I still use 0 as a test point?
Yes.
Okay, then one of them will be 0. Another one will be, I'll do 23.
Okay.
Little experiment. And then I need another one, right? Yeah.
Yep, you got to get all 3 regions. So just
Right.
something a little bit bigger. You're going to use a calculator, so it doesn't matter how big the numbers get. You just,
Okay. I'll use 57.
okay,
And keep it a little bit easy for my sake. A little bit
sounds
57.
good.
Yeah. Okay, let's do this. 55 minus 0 and then 0 minus 9. I got negative 495.
Okay, definitely negative.
Okay, now let's do 23. That's going to be positive and it's 448.
Okay, agreed.
Now 50. That's going to be negative.
Agreed. Now we're interested where it's greater than or equal to 0.
Mhm.
So we want this region in the middle here. Since it's greater than or equal to, is it going to be filled in or open circles at the end here?
It's going to be filled in circles.
Yes, so it includes those points. So your region is from 9 to 55. Sorry, bracket, like that. Now we need to, that's doing the math. We need to go back and actually give like a physical interpretation from the problem.
Okay.
Okay, so what we're saying here is that he needs to charge the price X. If you go back and look, let me snip it in maybe. So the price X is in dollars.
Right.
Okay, so actually it says that, yeah, it says that later on. Find the price in dollars at which Nathan can make a profit. You'd want to maybe give a sentence as the price. is from $9 to $55. And then if you add this little extra word inclusive, that means to include the endpoints.
Mhm. All right, just give me a second. All right, I wrote that.
Okay, that was a tough one. There was a lot to do there, and but you're
Money.
doing, yes. But hopefully the main thing to take away would be like this sign chart. If you think you got that down, you're doing real well.
Yeah, I got that chart down.
Okay. All right, so you mentioned us going back and looking at some previous assignments. Which do you
So
know?
yeah, I know which one it is because I have it pulled out. It's lesson 13. Now, when you share your screen, I can tell you where to look. It's not going to be in the um it will be like not in the full course lessons. That shows you everything, but when you go to, sorry if I sound really confusing. This is,
Well, I'm wondering if we should just redo the problem. Do you remember which problem it was from lesson 13?
oh yes, I do actually. It's 1 in 10.
1 in 10. Okay. Um, is this the projectile equation?
I think so. I can read what the teacher wants as well and what.
I'm yeah, I'm just trying to get that question. It's usually best to just redo it rather than to
Yeah.
try to figure out the error. Could you confirm if it's this one?
Yeah, it is. It says use the given function. I thought we did that.
What this is the what number indicates gravity in feet per second. Is that right, or is it something
Yes,
different?
it's that one.
Okay. So I remember making some comments to you like gravity is really none of these numbers. I guess I do need to look at the lesson. So can I see the feedback if I log in? Is that, or
Yeah,
how does that work?
yeah, you can see the feedback when you log in.
Okay, let me get to where I can do that, and I'll share that screen. Maybe I can make some sense from it. Just a moment here to get to where I can do that. Okay. All right. So we're in algebra 2. All right, and where to go from here?
You scroll down and you click on lesson 13,
Okay.
and that's where he'll tell you what he wants us to do.
Okay, use the given function. Okay, I see. So the answer here is much simpler than he just wants you to say it's minus 16, which actually is not correct, but
The hard way.
well, how do I explain this? I gently, I mean, I'm not trying to be difficult to you at all. It's that this is just not quite right. Okay, let me snip the feedback for number 10 as well, and then we can look at that together.
All right, so for number 1, do I just say the answer is negative 16?
I believe that's all he's looking for, which
Oh, really? We did all that work for nothing?
I can't.
That's just cold.
Yeah, it looks like the nice one things I see there though is you're doing real well in there. I made a lot of comments here, but the reason it's negative is because gravity's pointing down. Gravity, I will just leave it as that. If he just says the gravity constant in one of these coefficients, we'll just go minus 16, and that's it. You need units on that one as well. So that's, let me snip that in here. Feet per second squared. That could also have been an issue.
Okay.
All right, and then for number 10, factory, you want to know the production level, so how many units will minimize cost? I thought we did that. Okay, so let's go take a look at number 10 again.
All right.
All right, a factory produces lemon scented widgets. It's interesting. Do you like the lemon scented widgets?
Wait, lemon. What are lemon scented widgets exactly? Are those a thing?
Well, so widget is this generic word that's given to things that are made in a factory.
Uh-huh.
It's kind of it's an English-ism. It's like widget refers to a thing that you would make, but doesn't really refer to anything.
Mhm.
So lemon scented, like when I think of lemon scented, I think of maybe like dish soap or something, but that's what it is. So just think of like, if you don't like that, think of it as like lemon scented dish soap. Each dish soap is cheaper the more that are produced, and so on. If too many dish soaps are produced due to storage requirements, costs go up. The account for the factory says that the cost for producing X thousands, that's important. So when we get our X value is in thousands,
Got it.
meaning that we have to take our X value and multiply it by 1,000. And that may be what we did not do, not sure. Find the daily production level that will minimize the costs. So the graph of this thing looks like this, and
Mhm.
we're looking for what's called the vertex.
Got it.
Okay. So the vertex is always minus b over 2a.
Mhm.
So a is 0.04, b is minus 8.504, and you have to put those values into this equation. So it's minus parentheses minus 8.504 over 2 times 0.04.
Mhm.
So go ahead and open up Desmos, or I can send you the link if needed.
No, I have it opened already from okay, so I will now do that. Okay. God, 106.3.
Yes. Now the problem with this answer, like I mentioned up here, is you have to multiply it by 1,000.
So do I now? I multiply times 1,000.
Yes.
That's gonna be 106,000. Like, I, yeah,
You said it correct. 106,000 and then 300,
yeah.
and then you want to add in the word widgets.
Okay. Right.
Okay, so that is the production level that will minimize cost. So your instructor is a stickler here for units and for indicating the full answer. So even though our answer was correct, if we had said, because it's in thousands of units, he apparently wanted you to multiply by 1,000. So now you have it.
Now we know.
Now you know. Okay. If you don't have something new to work on, there's a few things I think that might be worth working on with you based on this unit.
All
Or
right.
if you need us to go back and look at anything else from previous assignments.
No, I think we're good. Like, um, with without looking back, I'm just gonna take a photo of everything so far that we did, so I can upload it to my, so I can send
Sound,
it to myself, so then I can
sounds
upload.
good.
Okay, that's. You can tell me what we need to work on. I'll listen. I keep.
Well, it's best if you're ready to work on some problems, because I will give you a problem pretty quickly here.
some reviews. Okay, I got the revisions sent. Now I just have to take a photo of the lesson that we finished. Sorry, I'm taking a little bit longer. I just want to make sure that everything is shown in the photo. Okay, I'm ready.
Okay, so we're gonna look at the different types of factoring. So let's start with perfect square trinomials.
Okay.
So I'm going to give you a couple that we've done already. You did this one earlier, and you told me that this was x minus 7 squared. You originally told me that it was x minus 7 times x minus 7, which is
Yeah.
true. It can also be written this way. So let's say I gave you something like this, x squared minus 4x plus 4. What would go in parentheses here on the right?
Okay, like x plus 4, and I would say x minus 1.
Okay, so let's look back at how you got the 7. The 7 is two things. It's the square root of 49 and it's half of 14.
Yes.
What is the square root of 4?
Oh, sorry, 2.
And is that half of this number?
Yes.
Yes, it is.
I was thinking of something else. I don't work well in the morning.
It's okay. All right, so how about this one here? What is the square root of the last number? And then is it half of this number?
Oh, 5.
So x minus 5. Where do you think the minus comes from? Like, why is it minus in here? What do you see as the pattern?
Because of the 14x, and also because you want it to be nice and perfect, like it says up there, perfect square.
So because the negative here is what causes it to be negative here, because similarly, let me do this in blue, there are the positive ones. So x squared plus 14x plus 49 becomes x plus 7 squared. X squared plus 4x plus 4 becomes x plus 2 squared. Do you notice the only difference is the sign here and the sign in the answer?
Yeah.
Okay. The last one here, x squared plus 10x plus 25 equals x plus 5 squared. So the important thing here is to be able to recognize the form. You know, if it's negative, the answer is going to have a negative. If it's positive, it's going to be positive. All right, so let me give you a couple of examples here to think about. Okay, I want you to help me factor each of these, please.
Okay.
Or you can work them out and give me the answer here at the end.
Let's work together for this, honestly. So for the first one, x squared minus 18x plus 81, we would use 9.
So tell me, I want you to tell me what goes in parentheses in each of these.
X plus 9 and x minus 9.
Okay, let's go back and look here. Notice we only had one thing in parentheses.
Oh yeah, so it would be x minus 9.
Yes. Good. Okay, how about for the next one here?
X minus 1.
Good. And the last one?
X plus 3.
You got it. So these aren't very difficult when you know, when I say, hey, it's a perfect square trinomial. If I tell you what it is, you know how to do it. It's the challenge is when I give you a bunch of them that are mixed together that you may not be able to do this. So
Yeah.
let's look at difference of squares. We've already looked at this a little bit today, but we're going to make them just a tiny bit more difficult. So earlier you did some problems like this: x squared minus 9, which is x minus 3, x plus 3. Notice with difference of squares, there's only two terms. We did one earlier, x squared minus 64, x minus 8, x plus 8. All right. So notice the pattern here. When there's two terms and there's a difference, it becomes negative and positive.
Right.
Negative and positive. So here's a couple for you to try here. Do you need some time to get this down, or can I just give you some example problems?
You can give me some example problems.
All right. I like to clear the screen. That's why I ask, because I don't want you to, I want to see if you can short-term memory, stuff like that. X squared minus 4, x squared minus 36, x squared minus 1.
So for x squared minus 4, it's going to be x squared minus 2, x squared plus 2, basically.
Let's go back and look. Did you see any squares over here?
Sorry, not x squared. I don't know why. I meant x.
That's okay. And I'm not grading you on what you say, but what you write. So if you wrote down x minus 2, x plus 2, you would be correct.
That's what I did write down. So
good. That's good. It's not an oral exam. Math is not an oral exam.
I do not like math. But they're my worst nightmare. They're my enemy.
Okay. All right. How about the next one here?
Okay, it would be x. Wait, hold on. 36. What the fuck is this? Wait, hold on. The square root of 36.
You're welcome to use a calculator. I'm not anti-calculator.
Okay, good, because I actually forgot it real quick. Well, hold on. It would be 6. Sorry, my brain had a malfunction. And
What else?
minus 6 and x plus 6.
Good. How about
Sorry,
the last one here?
that was so easy, but I'm so tired that my brain can't function.
Well, you're doing great. Only 5 more minutes here. You're gonna, I'm gonna push you to the end though. We're gonna keep doing problems. So
Yeah.
how about the last one here?
X minus 1, x plus 1.
I'm reading a book and it talks about mind over the body, right?
Right.
The body's physically tired. The mind can take a lot more than we think it can. Okay, so the challenge here is when I mix them up, meaning I give you some of each. That's where the real challenge is. So if I give you like x squared minus 100, x squared minus 20x plus 100, x squared plus, let's go 16x plus 64, x squared minus 16. Okay, so the challenge here is like, can you distinguish between the two types that we've been doing?
Okay, yeah, I can try. So the first one is the difference of squares.
Yes.
The second one is perfect squares.
Perfect square trinomials. Yep.
Perfect square trinomials. Same thing with the third one, perfect square trinomials, and the last one is difference of squares.
Good. Now, you said the correct type. Can you execute and tell me the result of factoring them?
Yeah, it would be x minus 10 and x plus 10 for the first one.
Good.
The second one would be x minus 10 squared.
Good.
The third one would be x plus 8 squared.
Good.
And the last one will be x minus 4x plus 4.
Very good. Okay, so that's two of the three. The next type of factoring that you will see is what I call A equals 1. Okay, so it's something like this. X squared plus 6x plus 8. So A equals 1 refers to this leading coefficient. Okay, in this case, you're looking for two numbers that multiply to 8, but they have to add to 6.
Mhm.
Can you think of those two numbers?
4 inches.
This becomes x plus 4, x plus 2.
Mhm.
How about this one?
X plus 5, x plus 3. And
Good. Now, do you notice so far that your answers are both positive because all of these are positive?
yes.
So there's actually 4 cases. I call this case 1, where they're both positive.
Mhm.
Okay, meaning the answers are both positive, but this happens to be positive as well. So here's case 2. X squared minus 3x plus 2. Okay. Here's the answer. What do you notice about the answer?
They're both negative,
They're both negative.
and the reason that it's both negative is because when you multiply a negative together, it will be positive. So
That's right. So here's one for you to try.
okay. So in parentheses, it'd be x. Okay, hold on, so it's gonna be minus 6, x minus 6, and x minus 4.
Yes. Awesome. Okay. So we're almost out of time here. Real quick, I just want to find out, you said you're an ice skater, is that correct?
Yes.
So I'm sure you have certain like jumps that you do.
Yeah.
And factoring in some ways is like that. It's like if I tell you to do, what's a jump that you're really good at?
It's called a loop.
Okay, so if I'd say, hey, you're going to do a loop over and over again, you could do that all day long, I'm guessing, right?
I can do 5 in a row.
5 in a row. Is there a hard jump or something you're trying to figure out?
It's called an axle and it has 1.5
Axle.
rotations. So far, I'm trusting myself on that. It's just a challenge.
So the challenge in ice skating would be like if you had to do a loop and then an axle together. In the factoring world, it's like if I give you one of these and then I give you one of these and then one of these and one of these, like it's going back and forth. That's the challenge. It's not that you can't do any of this. It's the mixture of them all. That's the challenge
Right.
for most students. So just keep that in mind. If we have some more time, we'll definitely look at this again, but that'll take us to the